Hi guys, I'm going to make you do this Algebra 2 review today just because you know how I feel about things. I think it's important for you guys to know the background of where this stuff comes from instead of just using a calculator. So I want you to be aware of this. We're not going to use it a ton, but I want you to know it, and then partly because I'm gone, I think it's a good way to, I don't know, stall a little time and make sure that you're up to speed on where you need to be. Sorry about the sound on this thing. I know it sucks. I try to talk over that fan running on the computer. So we are doing binomial distributions, and when we do binomial distributions, it matters how many different ways you can arrange these things. So from Algebra 2, there's permutations and combinations. I don't know if you remember those. The first slide here is fundamental counting principle. You know this already. If I want to pick, there's 15 people in your class. If I want to pick 3 of you, first I have 15 people to pick from. After I pick one of those people, there's only 14 left. And then after I pick one of those, there's only 13 left. So there's my fundamental counting principle. That is how many people I could pick to get a group of 3 from your class. So if I wanted to make a yogurt parfait here, I could pick 2 types of yogurt times 5 types of fruit times 3 nuts, and that's how many different ways I can make a yogurt parfait. So this stuff, you know, we'll skip through this kind of fast. Password site consists of 4 digits followed by 2 letters. The letters A and Z are not used, and each digit or letter may be used more than once. So 4 digits, there's 10 digits we can choose from, and I can use each one more than once, so that's going to be 10 times 10 times 10 times 10. There's 26 letters in the alphabet, but A and Z are not used, that's 24. And I can use each of those more than once, so this is how many different passwords I can have. You are creating 4-digit combination for a lock on your locker. You can use 0 to 9, but cannot repeat the digits. So how many unique combinations are there? Well, I have 10 to choose from. After I pick one of them, there's only 9 left, and then there's 8 left, and then there's 7 left. That's how many different combinations I can have for my locker. Now, this part right here, I don't know if you know this terminology or not, what a factorial is. I think you should. But this is kind of just a factorial there, which can be written with an exclamation point. So if I want to do 6 factorial, it's 6 exclamation point, and I'm just doing 6 times 5 times 4 times 3 times 2 times 1. So you will have to do some of these in the homework, because I'm going to have you do a quick Algebra 2 homework. So if you didn't know what that exclamation point meant before, now you know. It just always means to do whatever number you're starting with, 6 times 5 times 4 times 3 times 1. That's 2 times 1. So suppose that you want to select and order 3 people from a group of 7. Now, there's a difference between a permutation and a combination. Permutations, the order definitely matters. So this says you want to pick so let's say we're picking a president, a vice president, and a secretary. Well, it matters which order I pick you in, because just because I pick one person, there's definitely a difference between whether they're the president or whether they're the secretary. So intuitively, if I want to do this, how many possible choices are there? Well, from the group of 7, I could pick all 7 of you. Then there's only 6 people left, so then I have 6 to choose from. And then there's 5 people left, I have 5 to choose from. This is what we're doing, so don't think too hard. If that's what you want to do, it's easier to type in your calculator like that. But if we want to write it in terms of factorials, I can write it like this. I can write 6 exclamation point over 4 exclamation point. Because if I think about what that really means, this is 6 times 5 times, you want me to talk to you right now? And this is 4 times 3 times 2 times 1. Well, what really happens here is these cancel, they cancel, and they cancel, and I'm back to what I originally had. So that is the formula for a permutation right here. If I want to do something, if I want to pick, so this the way you read this is it's 7 choose 3. So from 7 people, I want to pick 3 of them. If I want to write it in terms of factorials, it looks like this, because I really want the 7 times 6 times 5, and I'm just dividing by 4, 3, 2, 1 to get it to cancel out. So this is the formula. You need to focus more on combinations. That's what binomial distributions are made of. They're made of combinations. So combinations, the order does not matter. So an example of this would be, I need to pick 3 people to go run down to the office. I don't care who they are. I don't care what order I pick them in. It doesn't matter. There's no president, vice president. I just need 3 people to go. So I could pick Logan, then Leanna, then Bailey, or I could pick Bailey, then Logan, then Leanna. It really doesn't matter how I pick them. I just need those 3 people to go. So there's a difference on this. When we don't care about the order, we have to get our duplicates to cancel out. So here, let's go back. So here's the idea here. If I have 7 people, I am going to pick 3 of these. So 7, 6, 5 is what I want on top. Now, I don't need the 4, 3, 2, 1, but there are 6 different ways I can rearrange you 3 people. I need to cancel out those duplicates because I can arrange you. Me picking you different ways doesn't change who I'm picking, so I need to cancel out the duplicates. So how many different ways can I arrange 3 people? I can arrange you 3 people, 3, 2, 1. So I need to divide that duplicate out. I don't know if that makes any sense. So if I want to write this in terms of factorials, it's going to look like this. It's going to look like 7 factorial over 4 factorial, because that gives me the 7, 6, 5. It just cancels out the 4, 3, 2, 1. But then I have to divide out how many different ways I can arrange those 3 people. So then I have to divide by 3 factorial. So, and if you're really just trying to memorize, it's always going to add up to 7. So if 7 is what you're, well, it's always going to add up to the top. So whatever you're picking on top, the other 2 numbers are going to add up to that. So here's the formula if you want to write it down. So when it's a permutation, order does not matter. No, I'm lying. Sorry, order does matter. This is president, vice president, secretary. I take all the ways I can arrange them and divide out the ones not picked. So 7, 6, 5, and then I cancel out all the other ones. So 7 factorial over 4 factorial. I cancel out all the people I don't want. If the order does not matter, then I still need to do 7 factorial over 4 factorial. I still need to cancel out the ones I don't want, but I also need to divide out the different ways I can arrange those 3 people and the way they're going to duplicate. Okay? So here's the formula just written out nice and pretty. The way you read this is 7 choose 3. And this is what we are going to focus on for binomial distributions. Okay? So this is the last slide. So there are 12 different colored cubes in a bag. How many different ways can you draw a set of 4 cubes? Now, does it matter what order he draws them in? It really doesn't. We just want to know how many different ways can he get blue, red, green, yellow, or purple, brown, blue, yellow, or whatever. We just want to know what's going to end up on the table. So order does not matter. So I like to just think about it. It's going to be 12, 11, 10, 9, and then I need to divide out all the ways I could duplicate this, and I could duplicate that 4, 3, 2, 1. If you want to use the formula, it looks like this: 12 factorial. I'm choosing 4, so it's going to be 4 factorial, 8 factorial. If you want to order a pizza with 3 toppings, there's 23 different toppings available. Now, it doesn't matter whether you pick pepperoni mushroom ham, or ham pepperoni mushroom, or mushroom ham pepperoni. It's still the same pizza. So, I've got 23 toppings, and then 22, and then 21. And I need to divide out all the ways I could duplicate ham, mushroom, pepperoni. If you want to use the formula, it's going to be 23 factorial over 3 factorial, 20 factorial. We want to select 5 people from this class to take the AP test for all of you. How many different groups could we choose? Again, doesn't matter which 5 people I pick, doesn't matter who I pick first, just as long as they're in that group. So from this class, there's 15 students. So 15 factorial over 5 factorial, 10 factorial. So do the Algebra 2 worksheet, and we'll talk about that later. Have a good day. And remember, chat me. I'll be hopefully sitting around here just waiting for you to ask me questions. Thanks.